Hello everyone, today we will discuss multiplication in case of the vectors. The first point is that when a vector quantity is multiplied by a scalar quantity, it remains a vector quantity but its magnitude is varied. Here you can see that this is your vector A and it is equal to 2i plus 3j plus 5k. If we multiply it by a scalar quantity which is 3, then 3 vector A will be equal to 6i plus 9j plus 15k. So it is still a vector quantity. If you see here, the magnitude of this vector will be root 2 square plus 3 square plus 5 square. But if you see here, the magnitude of this vector 3a, it will be equal to root 6 square plus 9 square plus 15 square. So when a scalar quantity is multiplied by a vector quantity, it remains a vector quantity but its magnitude is varied. The second point is that when a vector quantity is multiplied by a vector quantity, so this can be done by two ways. The first way is called as the dot product and the second is called as the vector product or cross product. So when the two vector quantities are multiplied by a dot product, it produces a scalar quantity. But when two vector quantities are multiplied by a cross product, it produces a vector quantity. Now first we will discuss the dot product of the two vectors. Here you can see that there are two vectors. This is vector A and this is vector B. The angle between vector A and vector B is theta. Then the dot product of the two vectors can be written as A dot B is equal to vector A modulus vector B modulus cos theta, or this is whole a scalar quantity. In another way, you can write the dot product of the two vectors A dot B as vector A modulus and the scalar component of vector B along the vector A, that will be equal to B cos theta. So we can write A dot B as equal to AB cos theta. If your theta is here 0, then A dot B will be equal to AB because cos 0 is equal to 1. If your theta is 90, then A dot B will be equal to 0 because cos 90 is 0. If your theta is 180 degree, then A dot B will be equal to minus AB because cos 180 is equal to cos 90 plus 90 minus sin 90 and it will be equal to minus 1. It will give you minus AB. Further, the dot product in case of the two vectors follows the commutation law. You can write A dot B is equal to B dot A. Now see here that A dot B can be written as A B cos theta. Here theta is the angle between vector A and vector B. The other angle between vector A and vector B can be 360 minus theta. So if you write B dot A, then you can write it as vector B modulus vector A modulus cos 360 minus theta. So it will again give you the cos theta. So we can say that A dot B is equal to B dot A, or the commutation law is followed in case of the scalar product of the two vectors. Now we can define the scalar product of the two unit vectors as, here I, j, k are the unit vectors and I is the unit vector along x-axis, j is the unit vector along y-axis and k is the unit vector along the z-axis. So here you can see that I dot I is equal to j dot j is equal to k dot k and it is equal to 1. Similarly, I dot j, j dot k and k dot I is equal to 0. When we say I dot I is equal to 1, it happens as, when we say I dot I, it will give you unit vector I modulus unit vector I modulus. It is a self product, so the angle between the two unit vectors will be 0. So here magnitude of a unit vector, you know, it is equal to 1. So it will be 1 into 1, and cos 0 is equal to 1. So I dot I will be equal to 1. Similarly, we can prove I dot j is equal to 0 as unit vector I modulus, unit vector j modulus, and angle between I and j is 90 degree. So cos 90 is 0, so it will give you 0. Similarly, we can prove for the other vectors. Now there is a vector A and there is other vector A, then it is called as the self product, as we write A dot A, and it will be equal to A square. Now if there are two vectors like A is equal to AXI plus AYJ plus AZK, here AXI is the vector component of the vector A along the x-axis, AYJ is the vector component of the vector A along the y-axis, and AZK is the vector component of the vector A along the z-axis. Here AX, AY, AZ are the scalar component of the vector A along the x, y and z-axis. Similarly, we can say for the vector B, so if we take the dot product of the two vectors A and B, then it will be written as A dot B. So it will be equal to AX into BX plus AY into BY plus AZ into BZ. Because this time I dot I will give you 1, so it will be multiplied AX into BX. Similarly, J dot J will be 1, so you will get here a term AY BY. Then you will have K dot K, it will give you 1, so you will have a term AZ BZ. But if you multiply AXI dot, suppose BYJ, then I dot J will give you 0. Similarly, if you multiply AYJ dot BZK, then J dot K is equal to 0. So these terms will be 0. Only the self product terms in case of the unit vectors will produce the output, and that will be equal to AX BX plus AY BY plus AZ BZ. Now we will define the vector product or cross product of the two vectors. It is represented by a cross. Now the vector product of the two vectors is defined as A cross B, and it is equal to a vector quantity, and that is written as vector A modulus vector B modulus sine theta unit vector n. Here you see that this is the magnitude and this is your unit vector. So this whole term will represent a vector quantity, and the direction of the unit vector n is here perpendicular to both of the vector A and vector B when vector A and vector B are in a plane. The direction of the unit vector n can be defined as when vector A is swept in anticlockwise direction along the vector B, then the direction of the resultant vector unit vector n, it will be in upward direction. But if a vector B is swept in vector A direction, that is the direction of the clockwise, so here the resultant vector will be in the downward direction. It can be understood by the Maxwell right hand screw rule. So if you this is your screw here, you can see that if you rotate your vector B in vector A direction, then you see that the knob of the screw move in the downward direction. But if you rotate your vector A in vector B direction, that is the anti-clockwise direction, so the knob of the screw will move in the upward direction. So you can find in this way the direction of the resultant vector of the two vectors when they are multiplied by cross product. So here you can see that if you find the modulus of the two vectors which are in uh, cross product, then it will be equal to unit vector A modulus, unit vector B modulus, sin theta, unit vector n modulus. The modulus of the unit vector n will be equal to 1, so you can write it as AB sin theta. So here you can find unit vector n as A cross B upon A modulus B modulus sin theta, or you can write it as A cross B divided by A cross B whole modulus. Now similarly, if you write B cross A, then your B cross A will be here B modulus A modulus sin minus theta, because here your vector B is rotated in vector A direction. So here the angle is in clockwise direction, so it will be taken as negative. So it will be equal to minus AB sin theta unit vector n. So here you can see that the vector A cross B is not equal to vector B cross A, or you can write vector A cross B is equal to minus B cross A. Here it is also important to note that the unit vector n is perpendicular to both of the vector A and vector B. Now in case of the unit vectors, we can define the cross product of the unit vectors as I cross j is equal to k, j cross k is equal to I, and k cross I is equal to j. You can understand it by taking a circle. I, j, k are in anti-clockwise direction. So if the order of the two vectors are changed, then their cross product will give you a minus quantity, or that will be equal to the third quantity. So suppose here we write I cross k, so that will be equal to minus j, because here the order is not followed, because after I there must be j, but here after I multiplied by k, so it will give a minus j unit vector. So here you can see that if there is the self product of the two vectors in case of the vector product, then it will give you 0. So I cross I is 0, j cross j, k cross k, all are equal to 0, because here the angle between the two unit vectors is 0 in case of the cross product. So it will give you sin 0 is equal to 0. Now the cross product of the two vectors can also be defined as if vector A is equal to AXI plus AYJ plus AZK, and vector B is equal to BXI plus BYJ plus BZK, then we can define vector A cross vector B as, we will make the determinant. First we will write the unit vectors I, j, k here, then the scalar component of the vector A, that will be AX, AY, AZ, and then there is B, so we will write in the third row the scalar component of the vector B. So these will be Bx, By, Bz. Now suppose if there is B cross A, then in the second row we will write Bx, By, Bz, and in the third row we will write Ax, Ay, Az. So, but here A is written first, so in the second row we will write Ax, Ay, Az, and in the third row we will write Bx, By, Bz. Now we can open this determinant as I, Ay, By, Az, Bz minus j Ax, Bx, Az, Bz plus k Ax, Bx, Ay, By. Now if we open this determinant, which is of 2 by 2, then it will give you Ay, Bz minus Az, By, because this multiplication will give you a positive term and this multiplication will give you a negative term. So it will be A by Bz minus Az, By. Then it is minus j, then you will have here ax bx and then az bz. So this term will give you a positive term and this will give you a negative term. So it will be ax bz minus az bx. Then the third value, this will give you positive value and this will give you negative value. It will be unit vector k ax by minus a by bx, or you can say that your vector a cross b will be equal to I a by bz minus az by minus unit vector j ax bz minus az bx plus unit vector k ax by minus a by bx. Thank you.